So, good morning, dear students. Myself, Dr. Lingraju, Assistant Professor, Department of Physics, Government First Degree College, Tumkur. So, our college is affiliated to Tumkur University. So, today we will discuss the topic sawtooth wave intensity and loudness of sound. This topic is in a fourth semester physics subject of BSc Physics. So next we come to the first sawtooth wave. First here in the three waves, sawtooth, intensity and loudness. So first briefly we will discuss the sawtooth first, next intensity and loudness. Here we know sawtooth wave is a one kind of a non-sinusoidal waveform. It is so named based on its resemblance to the teeth of a plain toothed saw with a zero rake angle. Just we can observe zero rake angle. The convention is that a sawtooth wave, ಅದು ನೋಡಕತ್ತಾರ sawtooth wave ಅಂತ ಕರೀತಾರೆ. Sawtooth wave ramps upward and then sharply drops as it is a waveform with a triangular shape in which the rise time and the fall time are completely different. So knowing this from the diagrams, the rising time and also falling time is completely different. It is not in a uniform order. So knowing this concept, we will discuss the intensity variations. See, the intensity level will be going to variation with the range of frequencies. Here, simply if we say the frequency will be decreases, the intensity will be also decreases. The frequency will be increases, the intensity will be also increases. So like that here we are going to also observe from the graph. Next, we come to the applications of a sawtooth. Sawtooth wave are known for their huge magic. The sawtooth and square waves are common starting points used to create sounds and subtractive analog, virtual analog music synthesizers. And also the sawtooth wave is the form of the vertical and horizontal deflection signals used to generate a raster on CRT based television or monitor screens. Oscilloscopes also use as a wave for their horizontal deflections. Through they typically use electrostatic deflections. These are all the applications. One more other application is the first television receivers had controls allowing users to adjust the picture's vertical or horizontal linearity. Such controls were not present on later sets of stability of electrostatic components as improved. So knowing this one about a sawtooth wave, so we can explain based on this functioning of a sawtooth waves. So this sawtooth wave is also recalled as a Fourier analysis of a sawtooth wave. It is also recalled as a Fourier analysis of a sawtooth wave. now here we are going to explain this concept using another order, that is a intensity of sounds. So intensity of sounds. The rate of flow of sound. Energy through unit area held perpendicular to the direction of propagations of a sound is called as intensity of sound. So once again I repeat the definition. The rate of flow of a sound. Energy through unit area held perpendicular to the direction of propagations of a sound is called as the intensity of sound. So it is denoted by I. In SI unit, the intensity of a sound waveform is we called as a watt per square meter. Watt per square meter. So, of knowing this concept, here we express the equation is I is equal to 2 pi square v square a square rho v. So V means nu, that is we can say it as frequency of a sound wave. A is amplitude, rho is density, V is viscosity of the sound waves. So next, the above indicates that the intensity of a sound wave is directly proportional to. It is directly proportional to first one, the square of the frequency of the wave. And the intensity of a sound wave is directly proportional to the square of the amplitude of the wave. Next is the intensity of the sound wave is directly proportional to the density of the mediums. These are all related to the intensity of sound. The intensity of sound wave directly proportional to the velocity of the wave. So all are directly depends upon the variations of all these things. That is about intensity of sounds. Next is loudness of sound. So the degree of sensation produced in the ear is called loudness of sound. It is denoted by L. In SI unit, the loudness is sonic. It is depends on the sensitivity of the ear. According to Weber-Faster law, the loudness of a sound increases with intensity increases. According to this law, the loudness of a sound is sensed by proportional to the logarithm of intensities. Log of intensities. So here we can write as according to this law, both the quantities are related by L is proportional to log I. Here we can say K is a constant. So we can rewrite these equations. The loudness of a sound is given by L is equal to K log I, where K is a constant, I is the intensity of sound. So we can write it is in the form of dl by di. dl by di. So the dl by dl is called as a sensitiveness of the ear. That is equal to k by l. We can note that the sensitiveness of a ear decreases with increasing the intensity of the sound. So loudness depends on so many different factors. First one is density of the medium. Second one is intensity of the sound. Third one is the amplitude of the vibrations of the sounding body. Fourth one is distance from the sources of sound. Then fifth one is size of the source of sound. Sixth one is sensitivity of the ear on the listener. Of knowing these concepts, so we can discuss dependence on loudness. So what here we discuss only density important ಆಗಿರುತ್ತೆ. ಎಷ್ಟು ಸೌಂಡ್ ಅಂದರೆ density, how the particles are packed. So if the more particles are packed in densely, the sound is also more. Intensity of the sound. So intensity will be minimum or maximum. The sound is also directly proportional. The amplitude of the vibration of the sounding body. So how the amplitude will be going to variation takes place due to applying the force to the body. Vibration, how it is going to take the vibrations based on the amplitude will be going to changes. It also leads the how much loudness will be comes out from the body. The distance from the source of sound. How much distance we kept it from the materials. If it is minimum means loud, the sound will be more. If the distance will be maximum means the loud will be decreases. Size of the source of the sound, it is also very important. So here we know amplifiers. If the more value of the amplifier if you use means we get the maximum sound from the speaker. If the amplifier size will be very less means capacity will be very less means the sound output from the speaker is also very less. Similarly here also, so what kind of materials we used, that is the size of a source. If the source of a size will be increases means sound will be also more. So like that here we are going to explain. The sensitivity of the ear of the listener, that is also very important. So if we having some problems in a ear, so we can get the very good noise. So sensitivity is very less. If the sensitivity is more in the ear, so we can get it a very high sensitivity. That is about the loudness of a sound. And next, the third one is we come to the intensity level. The logarithmic of ratio of intensity of a sound to standard intensity is called intensity levels. The logarithmic ratio of intensity of a sound to standard intensity. Intensity of a sound to the standard intensity is called as intensity level. The intensity level, the lowest intensity of a sound at 1000 Hz to which a normal human ear can respond is taken as 10 to the power minus 2 watts per minute. This standard intensity is called threshold of audibility. This is considered as 0 or the standard of intensities. Intensity level is denoted by IL. It is given by IL is equal to log base 10 of I by I0, where I is intensity of sound and I0 is the standard intensity. If the value of IL is equal to 10 to the power minus 12 meter, SI unit the intensity level is bell. So bell means to define bell. Consider I by L. That is equal to log of base 10 I by I0. That is the definition of the bell. So knowing this one, 1 dB is equal to 1 by 10 bell. Decibel is defined as 1/10 of the bell. It is denoted by dB. It is given by dB is equal to 1 by 10. That is called as decibel. The decibel scale, the intensity level of a sound of intensity I is given by IL is equal to 10 log of base 10 I by I0 of dB. So the range of intensity level is audible sound from 0 decibel to 120 decibel at frequency of 1000 Hz. And now here we can observe some of the common intensity levels are tabulated below. So source of sound in the 3 different intensities. Intensity 1, intensity 2, intensity 3. That is also very different ranges. First one is watts per meter square, second one is in bell, in the third one is decibels. Threshold of hearing. You see, 10 to the power minus 2 for intensity, these are 0. Rusting of leaves, 10 to the power minus 2, very less. Intensity level 1 and 10. Whisper at the 1 meter distance. So, marketplace, see how much it is there. Siren at the distance of 300 meter. Threshold pain. So, like that, here we are going to explain the different order of intensities, what we are observing, to varying the changes of the sound systems. Next, the difference between the loudness and intensity of sound. Loudness and intensity. Loudness is, it is the amount of sensational produced in ear, thus it depends on its listener. It is the sound energy flowing across the area per unit time, hence it depends on the source of a sound and not on the listener. It is more of a physiological quantity than a physical quantity, and hence subjective in nature. Loudness, but intensity is purely physical quantity and hence objective in nature. Either is subjective nature or objective nature. Means it is directly recorded, it is not a directly. It cannot be measured directly. Loudness is measured in zones. It is measured in watts per meter squares. So, knowing all these things, I have referred all these concepts of loudness, intensities, and sound from these very important books. That is a Sundarajan, N, and group of different teachers explain, written a book around 2011 through a college physics book established or published from United Publishers. And one more another author, that is a very important textbook, the textbook of optics, published from S. Chan. The written of this book is Subramaniam, and also the remaining books are written from the teachers belongs to Tumkur University. First one is Mangala Gauri M, second one is Nagbhushan H, third one is Ramakrishna H. So, and also we are going to take on directly using some related research or internet media. So, we are going to explain it. So, it's about the loudness, intensity, so and also sound. So, like that, here we are going to explain the concept of the subject in this order of a loudness. Thank you one and all.